Hello, Algebra 1. Today we are going to talk about exponents. We're starting Unit 6, and it deals a lot with exponents and properties of exponents. So you may have learned some of this in middle school. We're actually doing two separate note pages today. They're both really short, just one page front and back. So we're going to start with this one, the 6.0 note page. So make sure you have that out. And we're just going to start by reviewing some of the basics about exponents that you probably learned at some point in middle school. Okay, so let's get started. So what are exponents? Well, they are basically a way to represent repeated multiplication. So for example, if you are going to do something like this, 4 times 4 times 4, another way to write that would be 4 to the third power. So that's an exponent. It just looks like a little number that's raised above the big number. Now, remember, this does not equal 12. I don't want you to think it equals 12. It does not mean 4 times 3. It means 4 times 4 times 4. So that's going to be actually a pretty big number. 4 times 4 is 16. And then 16 times 4 is 64. So just be careful with exponents. I always have a few students that want to just multiply these together, and that's just not how that works. Okay, so let's review a couple vocabulary words here real quick. So the little number up there, that's called the exponent. And then the big number that it's attached to, so this part right here, this is called the base. And then if you were to read that out loud, if you were to read what this says, this means x to the nth power. Okay, so another couple vocabulary words to remember. Sometimes some exponents have special names. If you raise something to the second power, another way to say that would just be squared. And you all know that already. We've been using that power in this class. So the power of 2, we call that squared. And then if something's being raised to the power of 3, that's called cubed. And anything else, you can just say, you know, fourth power, fifth power, etc. All right, some calculator tips, and I'm going to show you a calculator screen in a second. There's going to be some buttons that will be very helpful throughout this chapter. So you definitely want to know where the x squared button is. You're probably already familiar with that. We've been using it in this class a lot. And then for any other power, so let's say you want to take something like this, 3 to the 5th power. Instead of typing 3 times 3 times 3 times 3 times 3 in your calculator, you can just type it in like this. The button you're going to look for is something that looks like this. That's called a caret. It looks like a little up arrow. On some calculators, it looks like this, y to the x power. So just to show you real quick, and I want you guys to practice this right now. Try to type in 3 to the 5th power. It should tell you that it's equal to 243. So I want you to try to type that in, see if it works out. And if you're struggling, I'm going to show you where to find that in your calculators. So I'm going to pull up a little picture of a calculator here. And the caret button is located right here. So if you want to type that in, you'll just hit 3 and then hit the caret button and then hit the 5, and it should tell you what it is, okay? So another thing to remind you about, and this is really important, when you're dealing with a negative number, if you want to raise a negative number to a power, you must use parentheses. If you don't, your calculator will likely give you the wrong answer. So make sure you're putting the negative in the parentheses, and then the exponent would go out of the parentheses, okay? So let's just do some basic notation here. And again, most of this is going to be review for you. We're going to take these expressions and we're going to condense them into exponential notation. So 11 times 11, another way to write that would be 11 squared, because you're multiplying 11 by itself just 2 times. And then the value, that's just what it would equal. So 11 times 11 is 121. You can use a calculator for all of these. You don't have to do it by hand. You can go ahead and just type them in your calculator. All right, the next one, let's see, we have 1, 2, 3, 4, 5, 6, 7 twos. So this would be 2 to the 7th power. And then go ahead and practice typing that in your calculator. 2 to the 7th power gives us 128. Okay, same thing for the rest of these. This one would be negative 5 to the 4th power. And if you type that in correctly, it should tell you that it is 625. Once again, make sure you're using parentheses here. If your calculator told you that it was negative 625, that's probably because you typed it like this. If you type it like this, it's going to tell you that it's negative 625, but that's wrong because we know that when you multiply a negative times a negative, it turns into a positive. And that would happen here. All of these negatives should cancel out and turn positive. So make sure you're using those parentheses. Okay, next one, we have 1/4. So we're going to do 1/4 to the power of 3. When you're dealing with a fraction, you also want parentheses because what's happening here, think of this as 1 to the power of 3 over 4 to the power of 3. Both of those numbers would get raised to the power of 3. Now, you can type that in your calculator if you want to. You can use the fraction button, or you could just do them individually. You could do 1 to the third power, which is just 1, and then you could do 4 to the third power, which gives us 64. I do want you to leave these as fractions. I do not want you to use decimals for any of these. Okay, when you have two different numbers here, we have 7 times 7. Let's write that as 7 squared. And then we have 4 times 4 times 4. We'll write that as 4 to the third. And then you could just leave it like this. If you want to put a little multiplication dot in there, you can, but you don't have to. If the numbers are right next to each other, it implies that they're being multiplied. And then to evaluate that, you can type that in your calculator exactly how it looks. So you could do 7 squared, and then you could hit times 4 to the third. Now you might have to use your arrow keys depending on the calculator that you have, because sometimes when you start typing, it might do something like this: 7 squared times 4 to the third power. It might try to put all those numbers up there in that little exponent spot. So just use your arrow pad to get out of that. If you evaluated that correctly, it should be 3,136. And then finally, this last one here, they're a little bit out of order, but that's okay. We have an 8, an 8, an 8, an 8. That would be 8 to the fourth times negative 2 to the 1, 2, 3. So it would be negative 2 to the third, like that. And then that's going to be a pretty large number. So you guys can try to type that in. If you're typing it correctly, here's what you should be getting. Negative 32,768. All right, we're going to talk about a few more things on the back. So go ahead and flip it over when you're ready. Okay, most of this is just the same. So we have 2/3 here times 2/3. That would be 2/3 squared. And then 9 times 9 is 9 squared. And again, you can type that in your calculator to evaluate it. If you type it correctly, that's going to be 36. If you want to think of this using order of operations, remember when you square a fraction, you're squaring the top and the bottom. So that would be 2 squared, which is 4, over 3 squared, which is 9, and then 9 squared is 81. And then you could do 4/9 of 81. You could multiply these together. So you could just do 4 times 81 divided by 9, and that would give you 36. Okay, now let's talk about variables. So with the variables, you can simplify them the same way. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be a to the 9th power. Now we can't actually evaluate that, so I'm just going to leave that one blank because we don't know what a is equal to, so we're just going to leave it like this. If you have multiple variables, like 2 letters next to each other, you want to make sure you put that in parentheses. So we're going to do x, y, parentheses, to the 1, 2, 3, 4, 5, 5th power. So it should look like that. And then once again, we can't evaluate that. Okay, next one, we have a few different letters. Let's start with the r's. So 1, 2, so that would be r squared. And then for the s's, 1, 2, 3, 4, 5, s to the 5th. And for the t's, we have just 1, 2, 3, so t to the 3rd. And then you can just leave it like that. Some people like to put little dots in between these for multiplication, but you don't have to do that. And then again, we can't evaluate that one either. Okay, so here we have a combination of numbers and letters. So let's start with the numbers. Typically, you want to do your numbers first. So 9 times 9 times 9 would be 9 to the 3rd. And then for the k's, we have 1, 2, 3, 4, 5, 6. And that would be the exponential notation. Now, you can evaluate part of this, and we're going to do that. You can evaluate the 9 to the 3rd. So you can type that in your calculator if you'd like. So that would give us 729. And then the k's, we can't evaluate that, so we'll just put k to the 6th. Okay, next one, same thing here. We have two negative 7s, so that's negative 7 squared. And then we have 1, 2, 3 m's, and then 1, 2 n's. And then just like the last one, you can actually evaluate that negative 7. So negative 7 squared is positive 49. And then you can just bring over your variables. Okay, finally we have a quantity. We have a difference of two things that's being multiplied by itself 3 times. So to write that out, you can just keep it in parentheses. Oops, that's a 2. And it's being multiplied by itself 3 times. So we'll just raise it to the 3rd power. Now, there is a way to simplify this. We're not going to learn about that just yet. That comes up in a later chapter, later in the school year. So for now, we're just going to not evaluate that. You can just leave it like this. And then this last one, let's see, I'm going to start with the numbers here. We have 3 of these, so 6 to the 3rd. And then for that quantity, we can write that like this, a plus b squared, because there's 2 of them. Now, we can't evaluate the quantity just yet, but we can evaluate that 6 to the 3rd. So you can type that in your calculator. That would give us 216. All right, so that is just kind of the basics of how to represent expressions using exponents. Now we're going to talk about how to add and subtract expressions that have exponents. This is something, again, that you've probably done before. It's really just combining like terms. You just have to be careful because the only way you can combine like terms is if the variables and the exponents match perfectly. So I will show you what I mean by that once we get started. And then when you combine them together, you're only combining the coefficients. You're not changing any of the exponents. So I'll show you what I mean. Let's get started. So for this one, notice that the variables are the same. They both say x, and the exponents are the same. They both have 2. So you can add the coefficients. 5 plus 7, that would give us 12. And it would just be 12x squared. Don't make the mistake of doing this. Lots of times people want to do this. They want to add these and call it x to the 4th. That would not be correct. For the same reason that this would not be correct. If you go back to, earlier chapters, we used to do things like this. 3x plus 4x is 7x, right? Notice how we didn't change anything on the x. We didn't add up these exponents. Technically, those are both 1s. We didn't add those together to call it a 2, right? We just kept it as 7x. So same thing here. You don't ever want to change these exponents when you're adding. You just want to add the coefficients. Okay, moving on. This one here, same process. We're going to do negative 15 plus 4. So that gives us negative 11 and to the 5th. When you have multiple pieces, you have to just look for terms that kind of go together. So for example, the a squared, I don't see any other a squared in there, and I don't see any other b squared. The only thing that looks similar are these. This has an ab and this has an ab. So we can join those together. Just do 7 minus 10. That gives us negative 3. So that would be negative 3ab, and then you can just drop these other pieces. So that would be the final answer there. And then the rest of these, we're going to do them all the same, just combine like terms. So the next one, all of those exponents and variables match. So we're just going to add those all up. It would be 8 minus 7, which is 1, and then 1 plus 16 gives us 17. So that would be 17c to the 3rd. All right, for the next one, typically when you have multiple pieces like this, you want to start with the highest exponent that you see. Those should always be written first. That's called standard format. We're going to get more into that later on, but I always look for those highest exponents first. So 8k squared minus 2k squared, that would be 6k squared. And then now we're going to move on to the regular k's here. If I combine those, that gives me a negative 6k. Remember, treat that like it's a negative 1. And then the 7 would just be all by itself. So we're going to put that at the back. So that would be the answer for that one. Okay, next one, same thing. I'm going to start with the highest exponents here. So we're going to start with those. 4 minus 3 is 1. Now, you don't have to actually put the 1. You can put it if you want to. You can put a 1 right here if you'd like, but I typically don't do that for 1s. And the regular x's would come next. 2x plus 8x is 10x. And then finally, negative 7 plus negative 6 gives us negative 13. All right, let's do these last three. So the next one down here, let's see, we have negative 4a squared b. That looks like this term over here. See how they both have that a squared b, a squared b. So we can combine those together. Negative 4 plus 10 is 6. So that would be 6a squared b plus 7. Okay, on the next one, we have these two in the middle. Those look like terms, so we can combine those. 2 minus 7 is negative 5. So that would be negative 5xy. And then the other pieces, you can just drop them down. All right, next one. So let's start with the highest exponents. And notice we have x being squared and we have y being squared. I'm going to start with the x's. So 17 minus 8. That gives us 9, so 9x squared. And then the y squared would just be all by itself, so plus y squared. And then let's see, oh, these y's right here, negative y, positive y, those are going to cancel. If you add those together, that equals 0. So that means you don't even need to write it, just leave it off. And then finally, we have that negative 6 in the back. So that's the final answer there. Okay, so that was the basics. That kind of gets us started with this exponent unit that we're about to get into. Now you're going to take out the other note page. So we're going to do 6.1 part 1. So you should be able to have a copy of that. We're going to start another video that talks about that note page. One thing about this video, just to let you guys know, this video was made a long time ago. It's just one of the older videos that I have. You'll see what I mean once it gets started. It doesn't look like the actual note page, but all of the examples in the video are the exact same examples on this note page. So you will be able to follow along. You'll just have to look at the screen and watch the examples and then find those examples on the paper. You'll see what I mean once it gets started. It just doesn't look like this digital paper like you see here. It looks more like kind of like PowerPoint slides. But all the examples match up. So we're going to start this next video, and you're just going to follow along with those notes and fill in those notes as the video plays. All right, go ahead and start the next one.